A warm greeting to everyone. I am D.M.Kalai Selvi, Assistant Professor, CSE Department, RMD Engineering College. The subject code is 22CS201, Data Structures, Theory Courses with Laboratory Components, second semester, Unit 5, Sorting Algorithm. In Unit 5, different sorting algorithms are available: insertion sort, double sort, merge sort, shell sort. Now we are going to see insertion sort. Sorting is the way of arranging the data in the memory either in ascending order or descending order. While some elements are unsorted, so using linear search, find the location in the sorted positions where the first element of the unsorted position should be inserted. Now, I explain with the list of items. Here, this is a list of items. First, using a linear search, you will be splitting the list array into two things: sorted array and unsorted array. Sorted array, unsorted array. The unsorted array will have the entire list of items. For example, 45. I'm taking only a small number of items from the list here for explanation purpose. So this is an unsorted array. Initially sorted array will be the containing the value null. Now I'm going to pick the using linear search. I will be picking the first element from the unsorted array. So the remaining elements 79, 13, 36 will be in the unsorted array. 45 will be in the sorted array. At the next step, I'm going to pick the next element 79, and if I'm going to comparing 45 and 79, so 45 is the least. So 45 will be at the first and next will be 79. So the remaining element 13 and 36. Now I'm going to pick the next element 45, 79 and 13. So 13, when you comparing 13, you comparing 79 and 13, 13 is the smallest. So you go for a swapping. So the 13 will be thirteen will be swapped to the correct position, that is in this type of sorting, we'll be inserting the elements at the correct position in a sorted array. The next is 36. So after 36, the correct position for 36 will be next to 13. So we are inserting. So this is an example for an insertion array. So the entire list will be splitting into sorted and unsorted. So if you consider this is an initial array, you'll be inserting if at the correct position. This is the corresponding algorithm. We'll be checking each element, and the smallest will be inserted at the first. So it will be under a for loop starting from 1 to array length. The next position will be value. Next position value will be preport to the previous one. So outer loop, this is the outer times, inner while loop, inner times. So this will be the inner loop will be running up to while comparing, it will compare, and if it will run only if it has if there is a need of a swapping. By big O notation, the best case will work for n minus 1 times. Worst case will work for n into n minus 1 by 2. Next type of sorting is bubble sort. It will be checking two items, that is a pair of items will list, and there will be a swapping at each case. So the total number of passes, a list of item of n, a list of n items will go under n minus 1 passes. So consider 1 and 23. 1 is the least, so there is no need of swapping. When you compare 23 and when you consider 23 and 2, there is need of a swap. So 2 and 23 swap. Next item 56 and 9, there need of a swap. And then so 9 and 56. What's the next item? 9 and 56, 56 and 8, there need of a swap. 56 and 10, there need of a swap. 56 and 100, there is no need of a swap. Then after that, we again check 1 and 2, there is no need of a swap. 2 and 23, no need of a swap. 23 and 9, there need of a swap. So 9 and 23 will get swapped. And then 23 and 8, if you compare, the need of a swap. So 8 is swapped before. Then comparing 23 and 10, the need of a swap. And remaining is there is no need of a swap. So this will be the sorted for the second traversal. So it will be running with the starting from with the while loop, I value equal to 0 and I length to the from 0 to n minus 1. It will compare the pair of items next to it, and there will be a swapping if the item if there is a need of a swapping if the next item is the bigger one than the previous one. time cost, number of comparison and moves depends on the list, number of items in the list. Thank you.